Hello, this is Michael Steinbacher with EU Geology Earth News. Today we're going to look at a place called Nelson, Nevada, south of Las Vegas up here. Here's the Colorado River. As you come down from Boulder City, there's a road that takes you to Nelson. So I'll zoom in here. I hope this isn't too disorienting. But here's 95 coming south, and here's a road that takes you to Nelson, which is over here. Let me zoom in a little more, get a better feel for it. The town's here. This is the El Dorado gold mine. There's mines all over this area. I don't think any of them are actually working right now. They're all retired or they've been played out. But you have all these ridges that are really kind of interesting. This is what they look like in terrain using radar to see the formations. Now we're going to look at it with some different ways of looking. This is Google Earth. We're looking north. Here's Nelson. The mine's down here. This is rhyolite, magma, supposedly, that came up from below. And then over millions of years, hydrothermal vents found weak spots, faults, and oozed into it. I guess high pressure oozing. But it would take a long time to make veins of quartz, which are hexagons, many times with lots of gold in it. And that's what they look for, are these veins of quartz that go through the rhyolite that supposedly came up, got close enough to the surface of the earth or broke through so that it cooled quickly and didn't make a lot of crystals the way granite does. So this is quite common to find gold associated with rhyolite. This is granitic up here. Supposedly it bubbled up from below and did not get to the surface and cooled slowly, making lots and lots of crystals. All of these formations trend to the east over on this side. This to me is windward, 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 even the granite. And the cliffs on the west side, on the left, are leeward, and that's what they make. Now we're going to look at this with some photographs. Here we're looking north, down pretty close to the El Dorado mine. And you can see that all of these trend towards the right, towards the east. Even this one down here trends towards the right, towards the east. I'll zoom in. I hope this isn't too disorienting. But you can see the detail here and how this all works and how I see layer after layer building up on the top into the direction of the wind. So at one time, this wasn't here and this was, and then this got spackled on top of it with the wind blowing towards the left, the west. This is another similar area, again looking towards the north. You can see that everything trends to the right. And this is again right across the street from the gold mine, full of these quartz veins. I'm of the opinion that the quartz veins are probably electrically produced after deposition. There could be a scenario where the quartz veins are part of the deposition process, but it doesn't seem like that's the case. It seems like there might be currents that are going to ground and then are attracting silicon dioxide, making hexagon quartz that's full of different types of minerals. But this will be a work in progress. I mentioned the granite earlier. This is the granitic area, and this also trends to the east. Supposedly it came from below, didn't get to the surface, cooled very slowly because of that, and then what was above it eroded away. But that's awfully convenient, being on the right-hand side of this, what looks like windward. It doesn't seem to have bubbled up from below. Now I'll show you an image of it. This is the granite. You can see that it trends to the east, the same way everything else does in the neighborhood. This is a different type of rock, and this is more like conglomerate. It seems as if conglomerate also accumulates, growing up and into the wind, and then the current density is increased. Different types of material are attracted. It gets hot enough so that the sand and dust is molten, and then you get these formations that might have something affect them after deposition, or this might be the process of deposition. But there's going to be quartz involved here. There's not as much mining in the granite apparently as there is in the rhyolite. So you have this mixing and sorting that's probably electrical, depending on the current density and what material is available, what's being attracted, and in some cases probably repelled. Just to show how extensive this all is, here's the town of Nelson. I'm down here looking north, up in this direction. So we're no longer over by the El Dorado mine. We're now up here, and we're going to be looking north. And once again, everything is trending back to the right, which is to the east. So does this look like it folded to you? Or does it look like these layers are individually laid down with the wind coming from right to left, with different types of material being sorted? In my mind, a Birkeland current is twisting and attracting different types of material. But again, I'm not an expert on this. I would love for Wall, Thornhill, Dr. Don Scott, Mel, C.J. Ransom to sit and discuss these things, looking at what's there and going, gee, what would actually cause that? Here's Nelson down here. I'm going to go up this way a little bit, and I'm up here looking east at these ridges so that we'll be able to see what the leeward side looks like, the cliff with the layers that would be covered up. If the wind had blown from the west at any time, it would have spackled what you're about to see, so none of this would be visible. The idea is that the wind had to be from the east for these formations, if they are what I'm proposing, formation growing up and into the wind as opposed to folding. So this is leeward. We're looking east. The wind was blowing towards us. Each one of these layers is a different type of airborne material being pulled in. I believe this is granitic on the top, but I'm not certain. Again, I'm not a geologist. I'd love to have some opinions, but I believe that's the case here. So this is a Google Maps satellite view. This is the highway where we're just looking to the east. These are the ridges we just saw. If you go north, it gets interesting. I'm down around here looking this way, northeast, northeast, and here's an area that looks very molten, covered with cinders of basalt, and this is a basalt cliff where the wind seems to have been coming from the east. Same with these, but instead of granite and rhyolite, it's now basalt. It's molten. It makes flat layers on the top. It might be so hot that it produces flat surfaces because it's molten. And it gets to the ridge and it blows past. This is probably underwater down here from the flood coming from the equator in the model that I'm proposing. So now we're looking northeast. This is the area that seems to be basalt. This is a ridge that's covered with it. You can see the top layers are, the only explanation would be that the material was coming towards us. It certainly does not look like a flow up on top of this. Basalt would flow to the low point. Gravity controls basalt flows. That's fairly logical. This is the basalt. Here are the layers up here. You can even see way in the background that all of this is trending in basically the same direction towards the east, maybe a little bit northeast. So there's something going on here. There was a lot of electrical activity. It's a lot hotter than it is in most places. There seems to have been something centered south of Hoover Dam, which is where this is. So I believe this was a very highly energetic area. Thank you.